Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Today we're going to continue in the principle of fluid preparations. So in the last lecture we talked about the biological considerations, and we have to have a review. When we say principle, we said that we have biological, mechanical and aesthetics. Today we're going to talk about mechanical considerations. Mechanical considerations can be divided into three categories, as I said before: retention, resistance, and preventing deformation of the restoration. Retention form. What is retention? Retention means the feature of the tooth preparation that resist dislodgement of the crown in a vertical direction or along the path of placement. So it is the features I make to the tooth itself during my preparation to prevent the dislodgement of this crown or this restoration in a vertical direction. Retention prevents crown from being withdrawn in the direction of the line of insertion with bend on, minimum taper, maximum length, great surface area, surface roughness, thickness and type of fluting cements. Okay. Lack of retention is a common cause of crown failure. First, we have to talk about tapers. So we can see here a different degree of taperness. Taperness is conversion from cervical to the occlusal surface. Okay? So here we have a 0, here we have a 6, and the last one we have 25 degrees. Which one will have the greatest tightness? 100% is 0, but we can't achieve it in the clinic, so we made it 6 degrees. Okay? You can imagine in this picture, the blue color is a prepared tooth, okay, and the outer surface is a crown, okay. If we have a -6, we're gonna have an undercut. So in this clock you can see obviously 1 minute is equal to 5.5 degrees. Very critical. Okay, can we achieve it? Can we do it with our neck eye? No, we can't do it. Okay, so don't worry. Do not panic. You can't let the pair, you can let the pair dictate, okay, the angle of the paper, not you, not your hands, not your eyes. Okay, they manufacture the pair in a taper way, not in a straight way, as you can see, to prepare for preparation to have or to achieve this angle. Okay, so in fixed prosthodontics, all the pair we're gonna use in the clinic, it's very important, all the pair we're gonna use in the clinic should be tapered, okay, to get or to achieve this degree of taperness, which is very important. Okay, so just keep the handpiece steady and level. Okay, make it just parallel to the long axis of the tooth structure. Just make the head of the handpiece parallel to the long axis of the tooth structure. Okay, do not tilt it in any direction. Okay, away or near to the tooth. The head of the handpiece is representing the bear. If I can't see Mel in the posterior area, can't see the bear, okay, I can just see the head of the handpiece. It represents the pair. Okay, they are in the main line angle. Okay, if I let the pair, the end of the pair, from the finishing line, okay, from the end of my illustration, the cervical area, I'm going to create an undercut. You can obviously see the dot line, okay? The dot line represents the straight or the parallel pathway of the pair, the ideal way, okay? In the second picture of if you make it the end of the pair away from the margin, cervical margin, you're going to make an over taper preparations. Both pick are false. We can't make it in this way, okay? We have to be parallel to the long axis of the tooth structure. So you can see in this picture with the long and the short, okay, which is more retentive. So the questions, okay. So the longer clinical crowns with this degree of taperness are much more retentive than the shorter one, okay. If I have a good length and a good taperness, I'm going to have a good retention. The second point or factor affecting retention after taperness is the surface area. I'm going to have a great surface area, I'm going to have a more retention. So bigger tooth is good, more complex surface are good, surface roughness also is good for retention. Thick surface, some plastic, can make some plastic, right? Thicken surface, and the thickness and the type of the lutein cement play a major role in retention. The thin and strong cement is ideal. So we finished the retention, which was the first point in the mechanical considerations. Then we're going to shift to the resistant form. Define it as a feature of the tooth preparation that enhance the stability of the restoration and resist dislodgement along an axis other than the passive insertion or the vertical directions. So, it's a feature, simply, it is a feature I made to the reduction or to my tooth during my preparation to avoid any dislodgement in another direction than the vertical one. In the retention, I said along the vertical direction. In other direction than the vertical, it is a resistant form, okay? So I have to make my restoration stable, okay? So I have to prevent crown, I have to prevent it from rotation and twisting force. Rotation and twisting force comes from mastication and chewing effect, okay? Also, resistance is affected by the length, width, and degree of taperness, okay? You can see here, resistance to some extent differ from retention, okay? If I have a long one, and I have, you can see the error, okay, the blue error, representing my force. If the force the oral cavity pass in a way, not in a direction of the tooth itself, it's gonna dislodge or make my restoration unstable. All force should be transmitted to the abutment, okay? So adequate resistance depends on the following: the magnitude and the direction of the dislodgement force, the geometry of the tooth preparation, and the physical properties of the lutein cement, okay? As I said before, twisting may come from chewing habits, okay, functional habits, okay. As we can see in these pictures, he's making accessory slots and grooves to increase the retention. He's increasing the retentions, okay, by slots and grooves in the preparation to prevent rotation or moving of my illustration, mainly in the partial preparation, not complete preparation. The third point in the mechanical consideration is a structural durability or strength and rigidity. In another way, where if the material is too thin, it will flex, weave, and fracture. Okay, so I have to have a rigid and enough thickness of my illustrations. Okay, the tools must be prepared in such a way that it provides structural durability to the crown illustrations, which means that the crown illustration must be rigid enough not to flex or perforate. Okay, to be rigid, it must have a bulk of material, so sufficient amount of this structure must be removed without affecting the normal contour of the piece. Preparation features affecting structural durability are related to the axial and occlusal reductions. Okay. On preparing the occlusal surface, the reduction should follow the geometric plane. I have to follow the geometry, as we said. I have to be following the tooth geometry, okay? The occlusal surface. So making uniform thickness. I have to take care to the functional cusp. In the crowns, the occlusal surface of the posterior crowns, we have functioning cusp and non-functioning cusp. Okay, functioning cusp, as you know, they do a role in mastications. Non-functioning, they are not doing a role in mastications. So in functioning cusp, there is a great force on them. So I have to make more reduction to have more bulk of the materials to withstand the more forces they are received. Okay, we're gonna see it in next lectures, increasing the amount of reduction in this functioning cusp. In addition, I have to make bubbling, because normally in the functional cusp there is a bubble, okay, 45 degrees, so I have to make it. Okay, if I didn't make it, I'm gonna decrease the lifespan of my illustrations. Okay, axial reduction done to withstand forces and remain within the contours and provide enough space for the illustration. I have to take care in the axial reduction, not to ignore them. Okay, most of dentists ignore the axial walls. Okay, so they are affecting the structural durability of the illustrations. Here we can see obviously a very nice reductions, okay, with a bubbling, as we can see here, a nice bubbling, a nice occlusal geometry, a very nice finishing line. Finishing line. What is finishing line? Finishing line is a line separating the prepared tooth structure from unprepared one. It is a line where my reduction terminates, where my preparation terminates. Should be continuous, uniform, obvious. Okay. In the other pic, the second one, in A and B, you can see that he finished the reductions and he is checking the occlusal reduction. Okay, with a wax.